Can you hear me? Yes. Good evening, everybody. Thanks for coming. You know, we didn't plan on the snow. And I actually, if you did travel, I feel guilty about that. So hope you get home all right. You know, Glenn said that I read books for regular people, and people say, you're good at talking to regular people. I'm a regular people. So it's easier than you think. I have to stand over here because they're filming this and there's no light over there. And if there's light over there, then you can't see the screen. So I'm going to stand over here and hope that I don't fall off the stage. I'm going to move. I have an official Hanover College water mug here. So let's talk about nature's best hope. My idea of what nature's best hope is anyway. And I'll give you a spoiler. You're nature's best hope. So I'm really going to talk about why I think you're nature's best hope. But before we do that, let's talk about what E.O. Wilson's idea of nature's best hope was. He, of course, is a very famous professor at Harvard. He died the day after Christmas 2 years ago, and it was a terrible loss to the world of conservation. But one of the things that was consistent throughout his 60-plus years as a faculty member was his love of life on planet Earth and his efforts to save it. And he wanted to save it not just because he loved it, but because he knew it was essential to our own survival. So in 2016, he wrote this book, Half Earth, Our Planet's Fight for Life, and he had one simple message. He said, if we're going to save life anywhere on planet Earth, we're going to have to save nature. We're going to have to save functioning ecosystems on at least half of the planet. It's a very bold statement, and he spent most of the book talking about the science that supports that very bold statement. And then he ended the book. He didn't spend a lot of time telling us how we were going to save nature on half of planet Earth. Of course, to a conservation biologist, that's a great idea. We'll just put half the Earth aside, and all the things that are in trouble can be in that half. We'll be in the other half, and it'll be wonderful. The problem is half of terrestrial Earth is already in some form of agriculture. And we've got 8 billion people with all of our hardscape and roadways and detritus and airports in the other half, and we don't have a third half to put aside for nature. So how can we actually do this? That's really what I want to talk about today. I do think we can realize E.O. Wilson's dream, but we need a new approach to conservation to do that. Before we talk about that, though, let's talk about what happened on the East Coast in 2019, and again this year, actually across much of the country, had a very large oak mast. Members of the red oak group got together and decided to make their acorns at the same time. And that's what it looked like in a lot of places. Well, I'm easily entertained, so I took one of those acorns and I just stared at it. But I was rewarded because an insect started to chew its way out of the acorn. First it chewed a little hole for its head, then it forced its head through there, and it forced its entire body through that hole. It was a tight squeeze. And once it's out of the acorn, it's very dangerous for that insect larva because it's good to eat. A lot of things are after it. So it gets to safety by wiggling and squirming beneath the soil surface. It takes about 30 seconds. And once it's underground, it stretches in all directions and forms a chamber. And within that chamber, converts itself to a pupa. And then surprisingly, stays in that underground chamber as a pupa for 2 years. After 2 years, comes out as an acorn weevil. That's what an acorn weevil looks like. A lot of people think weevils have big noses because it looks like they do. That's actually an extension of the head capsule, and the mouth parts are way down there at the end of that extension. They take those mouth parts, chew a hole into the center of the acorn, turn around, lay an egg in that hole, and that is how the larva gets into the acorn. Why do they spend 2 years underground? Why don't they come out the next year the way most insects would? Well, it takes red oak acorns 18 months to complete their development. So if they came out the next year, there wouldn't be enough acorns for them. Of course, after they leave the acorn, it leaves a hole. Kind of like a true vacuum, and you know that nature abhors a vacuum. And in this case, she's filled it with 3 species of temnothorax ants, tiny little ants where the entire colony lives in the holes made by acorn weevils after they've left the acorns. And if scouts find a new hole in a new acorn, they get all excited because their old acorn's falling apart. So they tell everybody it's time to move the colony. Grab the larvae, grab the eggs, move the entire colony into the new acorn. That takes about 30 minutes. And then they post a guard there and make sure nobody else will come in. And that's where they live for the next 2 years until that acorn falls apart. What's my point with this little story? That's just one of literally millions of very specialized interactions, largely between animals and plants, that comprise the bulk of nature. This is another one, the relationship between jays and acorns. Jays are the primary disperser of oak acorns. They'll take an acorn, fly up to a mile, sometimes a mile and a half from the parent tree. Then they tap it below the surface of the soil. And the object is they're going to go back in the wintertime and have something to eat. But for every 4 acorns they bury, they only remember where one is. So for every 4 acorns they bury, they've actually planted 3 oak trees. And a single jay can bury 4,500 acorns in the fall. Specialized interaction between pileated woodpeckers and carpenter ants. That's what they rear their young on, carpenter ants. So you won't have pileated woodpeckers unless you have a lot of carpenter ants, and you won't have a lot of carpenter ants unless you have the big trees that make those carpenter ants. You won't have this bee, Andrena facilii, unless you have Facilia. That is the only plant, the only pollen that bee can rear its young on. And it turns out that pollen specialization is very common in our native bees. We have between 3,600 and 4,000 species of native bees in North America, and over a third of them can only reproduce on the pollen of particular plants. You won't have the Baltimore checker spot unless you have white turtlehead. I could talk all night, all week, all year about nature's specialized interactions. The point I want to make, though, is that most of these interactions, nature itself, today is on the ropes. And it's on the ropes because we didn't take Teddy Roosevelt's advice. Way back in 1908, Teddy heard that the state of Arizona was going to mine the Grand Canyon. So he went to the canyon, looked out over the edge, and he said, leave it as it is. And with those 5 words, he started the process of creating the Grand Canyon National Park. Well, we didn't leave most of the country as it was, particularly the lower 48 states. There's only about 5% of the lower 48 states that's anything close to its original pristine ecological condition, and those are largely mountaintops. And that's because we have logged the country repeatedly, we have tilled it, we have drained it, we have grazed it. Got 770 million acres of rangeland out there. That's 4.5 times the size of Texas dedicated to cattle. And of course, we've paved it or otherwise developed it. We have straightened our rivers and dammed them. You can spell that any way you want. We polluted our skies and changed our climate for centuries to come. We've drained our aquifers. We've introduced more than 3,300 species of plants from other continents, many of which are running amok in our natural areas. In short, we've carved up those natural areas into tiny remnants of their former selves. And each one of those remnants is too small and too isolated to sustain the amount of nature that we humans need. Because it is nature, it is functional ecosystems that keeps us alive on this planet. So you might wonder why we've done this. I don't know. But I suspect we thought that our nest, planet Earth, was so large we could foul it forever and there wouldn't be any consequences. But of course we were wrong about that. And that's why we're seeing some pretty scary headlines these days, like the insect apocalypse is here. What does it mean for the rest of life on Earth? Talking about global insect decline. Followed by this one, North America's lost 3 billion breeding birds in the last 50 years. That's a third of our North American bird population already gone. Now the UN says we're going to lose 1 million species to extinction in the next 20 years. And they said it 2 years ago, so now I guess it's the next 18 years. That is a prediction. It has not happened yet, and we've got to make sure it does not happen because those are the species that keep us alive on planet Earth. It's serious stuff we're talking about here. So I could go on talking about the pox that we humans have delivered upon the environment, thus upon all of our houses, as Shakespeare says. But that's not what this talk is about. This talk's about a cure for that pox. It's a cure that'll take small efforts from lots of people like you and me. But those efforts will deliver enormous physical, psychological, and environmental benefits to everybody. Years ago, Edwin Wade Teale said, we cannot make the world uninhabitable for other forms of life without making it uninhabitable for ourselves. It's just common sense, So let's return briefly to this headline. The insect apocalypse is here. What does it mean for the rest of life on Earth? Well, back to E.O. Wilson. He told us way back in 1987 what would happen if Earth did lose its insects. And he did it with this paper, The Little Things That Run the World. And again, his message was very clear. Life as we know it depends on insects. And if they were to disappear, so would most of our flowering plants. And if that happened, that would so drastically change energy flow through our terrestrial ecosystems that the food webs that support our vertebrate animals, our amphibians, our reptiles, our birds, and our mammals, those food webs would collapse and all those animals would disappear. The biosphere, the living portion of the Earth, would rot because we would have lost insect decomposers that rapidly turn over nutrients, and all we would have is bacteria and fungi. And humans wouldn't survive any of those drastic changes. Well, there is some good news here, and that is that none of that has to happen. We can save our insects, we can save our birds, we can save nature itself, but we are going to have to change the way we landscape to do it. Why is that? Well, remember, humans are products of nature. We are totally dependent on the life support that healthy ecosystems provide. We call them ecosystem services. These are just a few things that plants do every day that we depend on every day, like the production of oxygen. Pretty important. Clean water. Plants are cleaning our water and slowing its journey to the sea where it becomes too salty to use. Carbon capture, enormously important today. Plants are pulling carbon dioxide out of the atmosphere, using that carbon to build their own tissues through photosynthesis, and then they pump the extra carbon into the ground through their root system. Once it's in the ground, it's extremely stable. It can stay there thousands of years. Plants build topsoil, hold it in place. They prevent floods. They dampen severe weather. They convert sunlight into food. If we lose our plants, we're going to have to eat sunlight, and we'll all lose weight. What do animals do for plants? They provide pest control services. They pollinate nearly 90% of our flowering plants. They disperse plant seeds. So designing landscapes like this is just not a good idea. Landscapes that destroy the production of ecosystem services. Not a good idea. You know, it never was a good idea. But today it's a terrible idea because of those 8 billion people that are demanding more and more ecosystem services every single day. Now, we do have parks. We do have preserves. They're doing the best they can. But it's not good enough. And that's why we are now in the 6th great extinction event that the planet has ever experienced. So the solution to me is obvious. And we now have to start practicing conservation outside of parks and preserves, on landscapes just like that. There have been visionaries through the ages who have recognized that we humans needed to work on our relationship with planet Earth, and Aldo Leopold was one of the most eloquent. He wrote extensively in the first half of the 1900s. One of the things he said is that the oldest task in human history is to live in a piece of land without spoiling it. There have been indigenous groups that have been good at doing that, but our huge Western societies and our huge Asian societies are terrible at doing that. We habitually take more from the earth than it has to offer, completely wrecking an area, going to another area, doing the same thing, not sustainable behavior. But Aldo Leopold had a lot of faith in humans. He believed we were capable of developing what he called a land ethic. He knew we had to use the land. We had to farm and lumber and graze and mine and do all of those things. But he believed that we were capable of learning to do it gently enough that we did not destroy local ecosystems. That's what he called a land ethic, and he wrote about it in his most famous book, The Sand County Almanac. What he did not write about was developing a land ethic where we actually lived. And I'm not sure why that was, but I suspect that the notion that humans and nature cannot live together, we cannot coexist in the same place at the same time, that notion was so deeply embedded in the culture of Aldo Leopold's day, it remains in our own culture. He may not have recognized it as an option. What I want to argue this evening is that not only is living with nature an option, it is now the only viable option that's left to us. In the past, of course, conservationists, what they do? They worked exclusively where there weren't a lot of people. We now need to turn that on its head and practice conservation where there are a lot of people, because that's pretty much everywhere. And that means we've got to find ways for nature to thrive in human-dominated landscapes, not hang on by a thread, not get diminished every year, but thrive. Where shall we start? Well, back to private property. Most of the country, particularly the lower 48 states, is privately owned. 78% of the entire country is privately owned. 85.6% of the country east of the Mississippi is privately owned. If we don't practice conservation on private property, we're going to fail, and failure is not an option. Now, when I use the word conservation, I'm not using it exactly the way I mean. We do want to conserve any bits of nature that are left out there. That's been our conservation model for the last century, and we want to keep doing that. But it's not good enough. So now we have to go beyond conservation into restoration. We have to rebuild ecosystem function in all the places, or as many places as we can. But right away I hear, well, you're never going to put it back together again exactly the way it was. And that's probably correct. We've changed too many things. But we can reunite enough of those specialized interactions I opened the talk with to create ecosystem function again, even if it's not exactly what was on that space at some point in the past. But in order to do that, we have to start with the building blocks. Not all species contribute to ecosystem function equally. So we have to start with the most powerful groups. And there's two groups that we can't do without. One is the flowering plants, and of course the pollinators that allow those plants to reproduce. They are capturing energy from the sun, and through photosynthesis turning it into simple sugars and carbohydrates that are essentially the food that supports all the animals on the planet, with some tiny, tiny exceptions. So now we have all the food that animals need in plant parts, mostly in leaves. You have to get that energy to the animals or you don't have any animals. If you don't have any animals, you don't have functional ecosystems. Well, it turns out that most vertebrates don't eat plants directly. Most vertebrates eat invertebrates that ate those plants. Most of those invertebrates are insects, and not just any insects. Turns out caterpillars are enormously important in terms of transferring energy from plants to other animals. They are transferring more energy from plants to other animals than any other type of plant eater. So if we design landscapes that don't have a lot of caterpillars in them, they're going to have failed food webs and eventually failed ecosystems. Now I'm going to use the Carolina chickadee as an example. You've got the black-capped chickadee here. Practically the same bird. And of course, those are the birds that are our feeders all winter long, eating seeds, and we tend to think that's all chickadees need. Most of us think that's all most birds need, seeds. Well, even in the wintertime, only 50% of chickadees' diets is seeds. The other 50% is insects and spiders. And when it comes time to reproduce, their babies can't eat seeds at all, so they switch to invertebrates. And if they're in a healthy environment, they will rear their young exclusively caterpillars, and chickadees are not exceptions. 96% of our terrestrial birds rear their young on insects, and most of those insects are caterpillars. So there's something special about caterpillars. What is it? There's actually several things special about caterpillars, and one of them is that they're soft. So think of this guy as if he's a little sausage with a very thin wrapper. The thin wrapper is his exoskeleton. It's made of chitin. It's undigestible, but because they're soft, you can stuff them down the throat of your offspring without fear of injuring them. And if you've ever watched a parent bird rear their young, they're pretty rough. The beak's like a plunger. Just stuff it down there. Caterpillars are also relatively large prey items. One medium-sized caterpillar is equal to the biomass of 200 aphids. Now, some of our smaller birds do chase aphids around, but do you want to chase 200 aphids or get one caterpillar? They are nutritious. They're very high in fat, very high in protein, low percentage of chitin of exoskeleton compared to many other insects, particularly beetles. Beetles are not like little sausages, they're like little tanks. So much of a beetle is undigestible, and a lot of beetles have very sharp edges too. Then finally, it turns out that caterpillars are the best source of carotenoids for birds during the breeding season. Now I mentioned carotenoids not because I love organic chemistry, but because I'm a vertebrate, and you're a vertebrate, and birds are vertebrates. And we vertebrates cannot make our own carotenoids. We have to get our carotenoids from plants. Only plants make carotenoids. And we have to get them from plants because carotenoids are essential components of vertebrate diets. Where are the birds getting their carotenoids from, particularly during the breeding season? Well, from all those things they bring back to the nest, but look, carotenoid content is not equally distributed among bird prey items. Those two bars over there are types of caterpillars. They have far more carotenoids than other types of bird prey. Here are the adult caterpillars here, the moths and butterflies themselves. They have far fewer carotenoids because they're not eating the leaves. That's where the carotenoids are. And here's the earthworm way down here. So the early bird gets the worm, but he doesn't get any carotenoids when he gets the worm. So that study and several others are suggesting that caterpillars are not optional parts of most bird diets. They are essential parts of most bird diets. So let's just say most birds need caterpillars. The next question is, how many do they need? Is one or two enough, or one or two a day enough? It's a good question. So let's go back to Carolina chickadee. There's a lot of data on Carolina chickadees. How many caterpillars does it take to make a nest of Carolina chickadees? One or two is not enough. One or two a day is not enough. It takes thousands, 6,000 to 9,000 caterpillars, depending on the number of chicks in the nest, to get those chicks to the point where they leave the nest, when they fledge. And after they leave the nest, the parents continue to feed them caterpillars another 21 days, but they're flying all around, so nobody's been able to count that. So you're really talking about tens of thousands of caterpillars to get one clutch of a bird that's a third of an ounce to the point where they're independent. And guess what? After they're independent, they keep eating caterpillars. And if you want chickadees to breed in your nest, if you want chickadees to breed in your yard, which is your nest, I guess, you have to have all those caterpillars in your yard. because they only forage about 50 meters from the nest. They're not flying 5 miles down the road to the nearest woodlot. And that's true for most birds. They forage very close to the nest. So if we landscape in a way that does not have all those caterpillars, that's called insect decline. And it's really looking like insect decline is one of the major causes of the bird declines that people are measuring. We went to Rosenberg et al., that's a Smithsonian group that says we've lost 3 billion breeding birds in the last 50 years. And we divided the terrestrial bird species into 2 groups. The species that require insects, typically when they're breeding, and the species that do not require insects when they're breeding. So things like finches and doves and crossbills can actually make a little milk out of the seeds that they eat, and that's what they rear their young on. And look, the species that don't need insects didn't decline at all in the last 50 years. But the species that require insects declined on average 10 million individuals per species. That doesn't prove cause and effect, but it does suggest that as you take bird food away, you lose the birds. And look, it's not just birds that need caterpillars. This is the ornate box turtle. I think you've got them here, a little farther west, yeah? They used to be common, and they love caterpillars. They used to chase armyworm and cutworm populations around, eat hundreds of caterpillars a day. So all I'm trying to say here is that we need to raise the bar about what we're asking our landscapes to do. In the past, we've asked them to do one thing, be pretty. Now we're going to ask them to do 2 things, be pretty and ecologically functional at the same time. And that's not going to happen unless we put those caterpillars back. So how do we add caterpillars to landscapes? Well, you add the plants that support those caterpillars. Seems pretty straightforward, but there is a catch, and that is that most plants do not support a lot of caterpillars, which means we have to be fussy about which ones we put in our landscapes. And we have to be fussy about it because the caterpillars themselves are fussy about it, and the monarch butterfly illustrates it perfectly. You can have all the Callery pear, Bradford pear, all the privets, all the barberry, or the burning bush, all the ginkgos, all the hostas, all the things we typically landscape with in our yards, and you won't make a single monarch butterfly. The only thing that's going to make a monarch butterfly is one of the milkweeds. That's called host plant specialization, and it turns out that most insects that eat plants are host plant specialists. It can only eat particular plants. Why is that? Well, plants don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction, so they've loaded their leaves with nasty-tasting chemicals, secondary metabolic compounds that make those leaves either bitter or downright toxic. And if you don't believe me, in the spring, go out and eat a plant. See if you like it. You're not going to like it. It's a really effective defense. It keeps most of the insects of the world from eating most of the plants of the world, which is why it's green out there in the summertime. It's not because there's no insects out there that want to eat those plants. It's because most of the insects that are out there cannot eat most of the plants. They are too well protected. There's a reason it's hard to get our kids to eat their vegetables. They inherently know they're toxic. But we do know that insects eat plants. So how do they do that? How do they get around those chemical defenses? Well, this is where the specialization comes in. 90% of the insects that eat plants can only eat the plants for which they have particular adaptations that allow them to circumvent, to get around those chemical defenses. They've got enzymes that store and excrete and detoxify the particular defenses in that plant. They've got behavioral adaptations and life history adaptations that minimize their exposure to those defenses. But it takes a long period of interacting with the particular plant lineages for all those adaptations to fall into place. And once they do, the insect is locked into eating that particular plant lineage. So if you take the milkweeds out of your yard and replace them with hostas, the monarch's not going to start to make a living on hostas. It is locked into milkweeds, and it has 2 choices: fly away and find milkweeds someplace else, or starve to death. It turns out there's 3 kinds of plants out there. Plants that actually contribute energy to local food webs, plants that do not contribute energy to local food webs, and plants that remove energy from local food webs. The very best contributor in 84% of the counties in which they occur is one of our oaks. We got 91 species of oaks in this country, and they're contributing more energy to food webs than any other plant genus by far. A good example of a non-contributor would be a ginkgo biloba from Asia. It's a nice ornamental plant, has good fall color, but nothing eats a ginkgo, so it's not adding any energy to the local food web. And a good example of a detractor would be our friend Callery pear, Bradford pear. Not only is it not contributing energy, but it's not staying where we plant it. It's a major invasive species which displaces the plants that are contributing energy, those contributors, which the end result is you're detracting, you're losing energy from those food webs. So all I'm trying to say here is that plant choice matters. If we're going to rebuild ecosystems, we have to have functional food webs in those ecosystems, and that is not going to happen unless you choose the right plants. And I'm going to give you 3 examples of how well it works when you do choose the right plants, starting with my house, our house. My wife wants me to call it our house. In Oxford, Pennsylvania. She should, because she paid for it. But that's where we moved in the year 2000. To a farm that was broken up. It was a very old farm, been farmed almost 300 years. And the last thing they did before they broke up the farm was to mow it for hay. So we got one of those 10-acre parcels. And the idea was we're going to put it back together again, which we had never done before, by the way. So we didn't know what we were doing. One thing I did want to try was to see, well, gee, if I plant the host plant of a caterpillar that's a host plant specialist, that caterpillar come and make a living at our property. I've never done that before either, but the first one I tried was a Canadian owlet. I'd never even seen a Canadian owlet. And people say, why'd you choose a Canadian owlet? Well, I was looking through Dave Wagner's Caterpillars of Eastern North America, and I said, that's a pretty one. I think it is pretty. That's what the adult looks like, just like a leaf. Well, you're not going to have Canadian owlets unless you have its host plant, meadow-rue. We didn't have any meadow-rue. We didn't have much. So I got some meadow-rue seeds. I'm sure it grew there a long time ago, but the place was farmed to death for hundreds of years. Got some seeds from someplace, planted them. They grew very nicely. But this was early on, and I actually had very little faith that Canadian owlets would appear out of nowhere and find my little patch of meadow-rue. So I didn't even go out and check it for at least 2 months after I planted it. But then I was walking by for another reason, and I looked over. It was covered with Canadian owlets. They had found it right away. I am still impressed with that. So now we have a good population of Canadian owlets and meadow-rue. We've added 2 species to the property. The restoration has begun. Same thing with this beautiful moth, the goldenrod stowaway. That's actually a misnomer, has nothing to do with goldenrod. It's a specialist on this plant, Biden's aristosa, ditch daisy. We didn't have any Biden's aristosa, but I did know where there was some Bidens in a power line cut about 14 miles away. So I got some seeds, planted them at home. They grew very nicely. As a matter of fact, they took over my front yard last year. That's okay. So I had to wait a year for the goldenrod stowaway to find my patch of Bidens. It did, and now we've got a good population of both of those. So now we've added 4 species to the property. Wanted to see if the hackberry emperor could make a living at our house. Not because it's the most beautiful butterfly in the world, but because it belongs there. It's one of the species that ought to be there. Well, as its name suggests, it's a specialist on hackberry, on celtis. We didn't have any hackberry. So I planted a few hackberry trees. I had to wait 4 years for the hackberry emperor to find my trees, but they did, and now we've got a good population of both of those. We've added 6 species to the property, and that's how the restoration proceeded. I did not plant goldenrod, came in on its own. And along with it came many of the things that depend on goldenrod, like the beautiful brown-hooded owlet, the Arcigera flower moth, the goldenrod leaf miner, the distinct Sparaginothus, the goldenrod gall moth. There are 110 species of moths that use goldenrod in the mid-Atlantic states. I planted Virginia creeper. Yes, Virginia creeper. I hear some people don't like Virginia creeper. But I don't know why. It's a great native plant. It's got good fall color. It's a good ground cover. It can climb our trees without girdling them, without pulling them down. It makes valuable berries for the birds in the fall. And by valuable, I mean they are high in fat. Our migrating birds need sources of fat, and our overwintering birds need sources of fat. And those berries came from tiny little inconspicuous flowers. You don't even know when Virginia creeper is in bloom until you see this big cloud of native bees around it. Turns out Virginia creeper is an excellent pollinator plant. So remember, when you're making a pollinator garden, you're making it for the pollinators. If it's not big and showy for you, that's okay. I planted Virginia creeper because it's the best host plant for the large sphinx moth caterpillars that are a primary component of cardinal diets. Things like the Pandora sphinx and its beautiful adult, the lettered sphinx, the hog sphinx, the abbot sphinx, all on Virginia creeper. Want to see if I get the double-toothed prominent to make a living at our house, just because it's such a cool-looking caterpillar. Even if you don't like caterpillars, you got to like that guy. Well, it is a specialist on elm, particularly American elm. And of course, we didn't have any American elm. We lost it decades ago to the Dutch elm disease. But there are two big American elms at the University of Delaware that did not die. And every year they make a lot of seed. So the second year we there, I gathered up some seeds from the gutter. Native plants are easy. Planted them. They germinate in 6 days. They grow very quickly. Today, those trees are over 80 feet tall. And yes, they brought in the beautiful double-toothed prominent American elm. Want to see if I get the evening primrose moth to make a living in our house, just because it's beautiful. I like beauty like anybody else. We didn't have any evening primrose, so I planted evening primrose. The moth came, spends the day with his head stuffed in the flowers. Sometimes it's crowded in there, but it's always very cute. And I planted lots of oaks. Now, these are just examples of the plants we put back, and we're still adding plants, but I want to focus on oaks for a while because they are such important plants. That is the Bedford oak in Bedford, New York, Martha Stewart land. People argue about whether it's 400 years old or 500 years old. It's enormous. And I hear people say, I'm not going to plant an oak because I won't live long enough to enjoy it. And if you can only enjoy your oak when it's 400 years old, you're right, you won't. But if you can enjoy what your oak is contributing to local food webs, you can enjoy it right away. And remember, that's a new goal in landscaping. You can enjoy it right away, and I can say that with confidence because I planted most of my oaks as acorns, which means they were free, or 2-foot bare root whips. And immediately, they started to call in the moths that make the caterpillars that run the food web at our house. Things like the solitary oak leaf miner, Juvenil's dusky wing, the yellow-shouldered moth, Suzuki's promolactus, the red-washed caterpillar, the yellow-vested moth, the orange-tufted oneida, the spiny oak caterpillar, the two-spotted oak punky, the variable oak leaf caterpillar, the red-humped oakworm, the pink-striped oakworm, the hesitant dagger moth, the lesser oak dagger moth, the medium dagger moth, the greater oak dagger moth, the streaked dagger moth, the afflicted dagger moth, the crown bucolatrix, the orange-patched smoky wing, the white-blotched heterocampa, the oblique heterocampa, the red-line panapoda, the laugher, and literally hundreds more species of moths have come to the oaks. I love it when you clap for the oaks because they are the very best trees. And look, they come right away. This is a pin oak that's just popped its head above the leaves, and here's a caterpillar standing on the ground eating the leaves of that tree. And people say, he's going to kill your tree. No, an oven bird's going to come eat it in 20 minutes, and the tree will be fine. You don't have to wait decades or hundreds of years for your oak to start to support the local food web. It will do it right away. Now, that's what our yard looks like in the summertime, taken from pretty much the same picture or place where I took that first picture from. Just to show you, we put some plants back. And as I said, we're still adding plants. Now, my research has shown over the past, I guess it's been 20 years now, just how important caterpillars are. If you know the number of species of caterpillars in your local food web, moths, number of species of moths in your local food web, and I want to focus on moths, not butterflies. Butterflies are bad-tasting, day-flying moths. And because they're bad-tasting, they don't contribute a whole lot to local food webs. So if you know the number of species of moths in your local food web, you have a very good index of how productive that food web is. In other words, how many species is it supporting and how stable it is. So 6 years ago, I accepted the challenge to try to take a picture of every species of moth that's making a living at our house. I'm still at it. I'm up to 1,259 species that are there because we put the plants back. And we have 10 acres. Pennsylvania is 22.4 million acres. So on one tiny sliver of the state of Pennsylvania, we've got 48% of all the moths that occur in the entire state. And because so many of those species are types of bird food, we have recorded 62 species of birds that have bred on our 10 acres. Not flew by, but bred. Why am I telling you this? Well, this is another headline we see all the time. The World Wildlife Fund says that Earth has lost 2/3 of its wildlife since 1970. It's a terrible statistic. But I'm thinking, gee, not at our house. I'm convinced we have increased biodiversity by more than 2/3. It didn't take that long, and it wasn't that hard. We just put the plants back. What would happen if everybody put the plants back? We really could turn a lot of these headlines around. But will it work on smaller plots, let's say in suburbia? It's an excellent question. So let's go to Margie and Dan Terpstra's house in Kirkwood, Missouri. They have 0.6 acres, 18 times less land than Cindy and I have. They're in the middle of a development. When they moved into their house, the yard was choked with bush honeysuckle, armor honeysuckle, another invasive from Asia. So they got rid of that. They planted 70 species of native plants, put in a water feature that they call a bubbler, and then they started to count the birds that are using their yard. And they're up to 149 bird species, including 35 warbler species. Is anybody a birder in here? That's a great number. 35 warbler species. We've only recorded 8 warbler species at our house. So does it work on smaller properties? Absolutely. What about urban yards? Let's go to Pam Carlson's house in Chicago. And I mean in Chicago. Her property abuts O'Hare Airport. She has 1/10 of an acre, 3 times smaller than the average lot size in North America. She's not connected to any natural area at all. It's a tiny little island. It's a pretty island, because Pam is a native plant landscaper. So the next time somebody says you can't use native plants and have an attractive landscape, remember Pam's landscape. But she did the same thing. She got rid of her non-native plants, put in 60 species of native plants, including a water feature, and then she sat back and she says, with a glass of wine, and started to count the birds using her yard. And she's up to 125 bird species that have used her 1/10 of an acre in the middle of Chicago, including a woodcock. There's Pam's woodcock. So if you haven't seen a woodcock lately, go to Pam's house in Chicago. All right, there's 4 things we need to think about if we're going to succeed, and we need to succeed. And the first thing is we got to talk about that lawn that's out there. We got 44 million acres of lawn. That's the latest statistic I've seen. That's an area bigger than all of New England dedicated to an ecological deadscape. Why do we do that? Well, it's a status symbol. It's a status symbol. And we have to display our Halloween decorations and our Christmas decorations. But what if we cut that enormous area of lawn in half? What if we took spaces like this and turned it into this? I got this picture from Dan Getman. I've never met Dan Getman, but he had this giant lawn. And he said, look, I'm putting plants back. And he sent me the picture. He's very proud of it. Well, let's make the math simple. Let's say we got 40 million acres of lawn. We're going to cut that in half. That'll give us 20 million acres. That will be enough to create that homegrown national park that Glenn was talking about. How big is, and we're going to do it right at home. We're going to restore this 20 million acres right at home. How big will it be? It'll be bigger than the Adirondacks, plus Yellowstone, plus Yosemite, plus Grand Tetons, Canyonlands, Mount Rainier, North Cascades, Badlands National Park, Olympic National Park, Sequoia National Park, plus the Grand Canyon, plus Denali, which is huge, plus the Great Smoky Mountains. Add up all those parks, still less than 20 million acres. So Homegrown National Park is going to be the biggest park in the country. What do we get when we put a park at home? What do we get when we put some part of nature right where we live? We get the opportunity to interact with that part of nature. At our own time, our own pace, all we have to do is go outside, or maybe even just look out the window. We can avoid crowds. You know, if you go to a real national park, 375 million people there last year with you, so I know really what you're going to interact with. It's free. There's no admission fee. It's never closed no matter what pandemic or government closure comes down the pike. No travel hassles. You get to experience the natural world alone, which is important in terms of developing that unique relationship with Mother Nature, not mediated by somebody else. And it's particularly important for our poor kids who are suffering from nature deficit disorder, according to Richard Louv. So we're trying. We have 30 kids. We put them on a bus with a teacher. They drive for an hour to a natural area. They walk around for an hour. Teacher tells them not to touch anything. Then they get back in the bus and they go home, and that's their experience with the natural world, which I'm sure is better than nothing. But it's really been an experience with 30 other kids and a teacher telling them not to touch anything. If they have some part of nature right where they live, all they have to do is go outside, get to know it, fall in love with it, explore it alone. No parental supervision. When we hover over our kids, we're sending the message that this is dangerous stuff. This is something you should fear. And that is not a good message to send to the future stewards of the planet. If they're afraid to be a steward, if they don't know what good stewardship is, if they don't love being a good steward, they're going to be lousy stewards. And we can't afford any more lousy stewardship. Maybe they'll learn how to hunt lizards. I'm learning this from my own granddaughter, Zoe, who lives in Hawaii on a very modest patch of nature. It's a bit of lawn with a hedge, but there are anoa lizards there. And when she discovered that, she sent me this picture to describe very seriously how you hunt lizards. You get on the ground and you cover yourself with leaves and sticks so the lizards can't see you coming. Then you crawl very slowly towards the lizard. No smiling, serious business. You can wear your best dress, that's okay. But you sneak up on the lizard, you catch the lizard, you put it in an aquarium, you learn how to take care of that lizard. You learn how to be a good steward of it. You fall in love with that part of nature. Now, I don't think Zoe's going to be crawling on the ground in her best dress catching lizards the rest of her life. I don't think. She sent me this picture not long ago, so who knows. But I guarantee she's going to remember interacting with that little bit of nature the rest of her life, and I guarantee it's going to help her be a good steward of the planet. And if you want to join Homegrown National Park, you can do it. Go to our website, homegrownnationalpark.org, and register your property on the map. So your location and the amount of area you're going to be a good steward of. Maybe you really are going to reduce the area of lawn. Maybe you're going to plant an oak tree. Maybe you're going to put an aster in a flower pot. It doesn't matter how small an effort you make, but your little piece of your county then is going to light up. And you get to see how many other people in your county are members of Homegrown National Park. The object, of course, is to get the message that everybody is the future of conservation. We want that message to go viral across the country. We want the whole country to light up. Our mission is to regenerate biodiversity by motivating millions of people to plant those natives, remove invasives from our properties, and reshape our relationship with nature. We really do want people to reduce the lawn. Lawn doesn't accomplish any of the ecological goals all of our landscapes have to accomplish. And we want to replace some of that lawn with the plants that do accomplish those goals. We want to remove invasive plants. Most people do have invasive plants on their property and they don't even know it. If you're protecting any natural area, we want to keep doing that. There are real ecological products associated with Homegrown National Park. Significant increase in biodiversity is one of them. And I just think about what's happened at our house in southeastern Pennsylvania. Nature really is resilient. And you put those plants back, it will rebuild itself. Measurable reduction in invasive species. If everybody got rid of the invasive plants just on their property, we'd be 78% done. We'd be 85% done in the east. Good first step. Significant drawdown in atmospheric CO2. You know, turf grass is the very worst plant for sequestering carbon. If you replace it with anything else, you're going to sequester a whole lot more carbon. Put it in the plant, or the soil for permanent storage, and then help climate change. And we're going to start to create viable habitat outside of parks and preserves. Any bit of conservation we do outside of a park is going to help conservation inside of the park. There are also important sociological products associated with Homegrown National Park. National awareness, not just of what the problem is, but what the solution is and what our roles in those solutions are. We want to change the culture. We want people to recognize that nature's not optional. It's not just there for our entertainment. It is essential, and it's essential for everybody, which is why everybody owns responsibility for sustaining nature. We want to convert hope into action. Hope is good, but action is even better. And we want to merge existing conservation organizations like Audubon and National Wildlife Federation and Wild Ones and land conservancies. We want to merge them all onto one visual that we call the biodiversity map so that we can see how we're doing towards this national goal of 30-30. 30 by 30, we're going to save 30% of the US by 2030. Not if we don't count conservation on private property. Homegrown National Park's free. You register yourself for free, which means we are entirely supported by your generosity. So I look forward to your generosity. Okay, we're going to shrink the lawn. We're going to join Homegrown National Park. What plants should we put in the area of lawn that we remove? I'm going to argue that some of them have to be keystone plants. Remember what a keystone is? It's a stone in the middle of the Roman arch. You take it out of the arch, and the arch collapses. If you take keystone plants out of your local food web, the food web collapses because they're making most of the food. Just 14% of our native plants are making 90% of the caterpillar food that drives those food webs. So think of the keystone plants in the ecological house that you're building as the 2x4s that hold that house up. They are the support system. We cannot build a house out of wallpaper, and that's what we've been trying to do with our ornamentals for the last 100 years. What is the best keystone plant? We already mentioned it's one of the oaks In the mid-Atlantic states, they support 557 species of caterpillars, over 950 species nationwide. Again, no other plant genus comes close to that. But if you want to know the best plants, what the best keystone plants are where you live, you go to Native Plant Finder and the National Wildlife Federation website, put in your zip code, and the ranked list of the best woody plant genera and herbaceous plant genera for your county will pop up. And these are abbreviated lists. I just ran out of room. So the old excuse of, I don't know what to plant, that's just an excuse now. You do know what to plant. Native Plant Finder. Okay, we're going to shrink the lawn. We're going to use keystone plants. We're going to invite a lot of insects to our yard, and then we're going to kill them with our security light, which is not the goal. It does turn out that light pollution is one of the major causes of insect declines around the country, and these are all the ways that insects are killing our nocturnal, that lights are killing our nocturnal insects, particularly the moths that create the caterpillars that run our food webs. Seems like a disaster, but it's actually good news to me. It is good news because we have to stop insect declines. We've already lost more than 45% of the insects on the planet. And if we can stop that and reverse it by flicking a switch, we're getting off easy. There are a lot of switches to flick, but there's a lot of us to flick those switches. But right away I hear, well, gee, I can't turn the light out over my barn or over my garage or over my front porch because the bad man will come. Right, put a motion sensor on it, so it only turns on when the bad man does come. And the first thing you recognize is the bad man doesn't come very often. And if you don't want to do that, take the white bulb out of your security light and put in a yellow bulb. You can go to the hardware store now. They call them bug lights. It sounds like they're trying to kill insects, but they're not. Yellow wavelengths do not attract nocturnal insects. So if you put in a yellow light, either incandescent or LED, if you convert take the white bulb out of your security bulb and put in a yellow light, overnight you will save millions of insects across the country. And if we use LEDs, we save millions of dollars as well. So we're going to shrink the lawn, we're going to use keystone plants, we're going to modify our light system, then we're going to invite one of the mosquito foggers to come kill all of our insects. This is a booming business around the country. And they say it's okay because what we're fogging is a natural product. It's organic. And they are right. It is made by plants. It's pyrethroids that are made by chrysanthemums. So it is a natural organic product. But so is cyanide. So is ricin. So just because it's made by plant doesn't mean it's okay. They also say it only kills mosquitoes. And that's not even close to being accurate. This is the result of a mosquito fogging event on Kent Island in the Chesapeake. My friend happened to be there, and he picked up a handful of dead monarchs, but there were thousands of dead monarchs. It was in the middle of migration, and we're doing this all over the country, regardless of what's around there. It kills all the insects, kills all the monarchs, all the pollinators, all the things we're working hard to increase when we fog for those mosquitoes. The interesting thing, the ironic thing is, it doesn't control mosquitoes. So we're doing all that for nothing. Actually, we're paying big bucks to do that for nothing. If you really want to control mosquitoes, you do it in the larval stage. In order to control mosquitoes in the adult stage, you have to kill 90% of them. Mosquito foggers kill between 10 and 50%, so they're not even close to getting good control. If you want to control mosquitoes, you get a bucket, fill it full of water, put in a handful of straw or hay, put it out in the sun. For a couple days, it'll build up populations of diatoms and algae, and that is what mosquito larvae eat. So this becomes an irresistible brew to any female mosquito in your yard. They will preferentially lay their eggs in your bucket. Then you go to the hardware store and you get a sheet of mosquito dunks, $12 for a season's worth of control. This is Bacillus thuringiensis. It is the bacterium, the natural bacterium that only kills aquatic diptera. And the only aquatic diptera in your bucket is a mosquito larva. So it's targeted, it's cheap. If everybody did it, we really could control our mosquitoes without killing everything else. But if you don't want to kill anything, get a fan, plug it in, put it on your picnic table, and have your picnic there. Mosquitoes don't fly into a directed breeze. This actually works. Okay, the fourth thing we need to think about is how do we landscape in a way that allow those caterpillars, those essential caterpillars, to complete their development. I'm talking about how we landscape under our trees. I live in Chester County, Pennsylvania, where oaks support 511 species of caterpillars. A few of them, like the polyphemus moth, complete their development on the tree. The caterpillar eats the leaves, then it spins a cocoon and hangs from one of the branches, then it emerges as an adult, then it does it all over again. I wish everything did that, but most species don't. 94% of the species that are up there in those trees finish growing as caterpillars and they drop from the tree and they wiggle their way beneath the soil surface and pupate underground, or they spin a cocoon in the leaf litter that's under the tree. And that's the problem. There is no leaf litter under the tree. We don't tolerate it. It's messy. And we mow and compact the areas under our trees so that they are rock hard, which means when the caterpillars drop down in the middle of the summer, doubtful that any of them actually get underground to pupate. These are oak trees here. That becomes a serious ecological trap. The moths come in, lay their eggs, caterpillars develop, drop down, and die. And I am convinced that the way we landscape under our trees across the country is another major cause of insect declines. And of course, the cement landscape is not the answer either. Now, this is what most people do. They've got a tree in a yard. I've got a grad student now, Emma Jonas, who is measuring how well caterpillars do in a situation like this. But I guarantee they're going to do better in a layered landscape like that. That's soft landing. Caterpillars drop out of the trees. There's plenty of leaf litter down here. Nobody's going to mow it. It's not compacted soil. They can easily get underground. Survivorship will be much higher. This is where you can do your fancy spring ephemeral gardening. Put beds next to your trees. This is how you shrink the lawn. The bigger the bed, the better. The bigger the bed, the less lawn you have. Again, your tree will love it, and so will those caterpillars. Use our native ground covers liberally, things like wild ginger. This is native pachysandra. That's the Virginia creeper is a ground cover. Golden seal, May apples, foam flower, ferns. If you can see the ground, you don't have enough plants. Green mulch is the way to go. Again, your tree will love it, and so will those caterpillars. Former grad student Desiree Narango did a very nice study in the suburbs of Washington, D.C., and the results of her study suggest there's actually room for compromise in our plant choices. And compromise is a good thing. She had one simple question. How well do chickadee populations do in suburban landscapes that are dominated by native plants versus suburban landscapes that are dominated by the introduced ornamentals that we typically use? And when they're dominated by introduced ornamentals, they produce 75% fewer caterpillars. So right away, you've reduced the amount of bird food by 75%. They were 60% less likely to have breeding chickadees at all. So every landscape had a nest box up in, but the chickadees would come and look around and say, there's not enough food here. We're not even going to try to breed. If they did try to breed, they laid 1.5 fewer eggs. Those clutches were 29% less likely to survive at all. If they did survive, they produced 1.2 fewer fledglings, and it took them 1.5 days longer to do that. And if you put all that into a population growth model as a function of the percentage of non-native woody plant biomass in your yard, from none to 100%, this is what you get. We looked at woody plants because that's where chickadees forage, on woody plants. This dotted line is replacement rate. That is the rate at which the population has to make babies to replace the adults that die every year. Chickadees don't live very long. And if you reproduce at this rate, you have a sustainable population. It's not growing, but it's not shrinking either. If you make more babies than adults die, anything above that line, then you have a growing population. And that's what happens when you have very few non-native plants. But if you make fewer babies than adults die, and that's what happens when you're below the line here, then you have an unsustainable shrinking population, and that's out here with a whole bunch of non-native plants. So right here is where those lines intersect. So liberally speaking, you can have up to 30% of your woody plant biomass on your yard non-native without destroying your local food web. That's the compromise we're talking about. Now, we can't tolerate any invasive plants. They're just ecological tumors. They escape and they castrate our local ecosystems. But not all ornamental plants are invasive. Remember Dan Getman? That's a ginkgo. Did you pick that up the first time? Why does Dan have a ginkgo in his native planting? Because Dan's wife likes ginkgos, and she said, Dan, I want a ginkgo. So Dan's a nice guy. He gave her a ginkgo. The question is that ginkgo going to destroy the productivity of this landscape? No. Is it going to escape and wreck the woodlot? No. It's just there. It's not contributing, it's just there. So I like to think of plants that are just there as if they're statues. So there you go, there's Dan's statue. Now, if everything was a statue, obviously his landscape would not be very productive. But it's not the presence of non-native plants that destroys local food webs. It is the absence of the native plants that drive those food webs. If we increase the percentage of these, we can tolerate many of these. Can we use native plants in formal landscapes? Of course we can. This is a Lynn O'Shaughnessy design taken by a drone 400 feet up. You don't get more formal than that, and every single plant in that landscape is a native plant. Formality is a function of the design. It's not a function of the plants in the design. Our native plants are used in formal designs in Europe every day, and they love them over there. If Europeans can love our native plants, maybe we can too. Can we get a pollinator garden into a residential landscape like this without offending anybody? Of course we can. Put a little fence around it. It formalizes it. It tells your neighbor that it's not a bunch of weeds you forgot to mow. It's pretty when it's in bloom. It's servicing several species of bees. Now, it's not very big. It could be bigger. But if everybody did it, it would help a lot. Help what? Help make pollinators. Why do we need pollinators? Well, the media tells you need pollinators because they're pollinating 1/3 of our crops. It's actually about 1/12 of our crops. And I hear people say, I don't live next to a farm, so I don't need any pollinators. Forget the agriculture argument. We need pollinators everywhere. Everywhere we need plants, which is everywhere, because they're pollinating 80% of those plants and 90% of the flowering plants. How about this? Drew Latham design, much bigger. Imagine the amount of life supported here versus the amount of life supported here. Seems like a no-brainer. Can municipalities help us live with nature? Yes, they can, and more of them are doing it. Minnesota's been doing it for a while. It's got a cost-sharing program that is paying people to reduce or replace their lawn with appropriate Minnesota prairie plants. It's very popular. Pennsylvania has a similar program now. There's an island off Florida, I think it's Marco Island, that is paying residents to allow burrowing owls, listed species, to burrow in the front yard. That's the way the Endangered Species Act should have been written, with carrots rather than sticks. If you have an endangered species on your property, we're going to pay you to take care of it, rather than fine you if you use your property. Everybody would want an endangered species. Put a bounty on these invasive ornamentals like calorie pear. That's what St. Louis, Missouri did, Fayetteville, Arkansas, North Carolina. If you take out a Bradford pear, you get a free tree replacement. Public utilities are giving people $100 coupons to put in water-efficient native plants. And, of course, the big lawn reduction programs in the far west, particularly California, this is going up. For every square foot of lawn you remove, you get a $3 rebate. And if you want more information on all of those programs, memorize that. All right, I think we've made 3 missteps in the early years of conservation. And this first one's important. We're starting to think of nature as if it's optional. We like nature. We like to bird watch. We like to go for a hike, but it's not essential. You know, Congress has labeled the budget for the national park system as non-essential. Well, if it's not essential, when push comes to shove, when resources are in short supply, which is always, it means nature will take a back seat. I went to the Cincinnati Zoo before the virus broke out, and there's this wall-sized poster there, which to me epitomizes our society's view of conservation. We want to save wildlife, save nature, so that future generations can enjoy it. It was Teddy Roosevelt's argument for creating the national park system. We want to save these beautiful places so that future generations can enjoy it. And I understand that because nature is enormously entertaining. But it's much more than that. We need to save nature so that we have future generations. A little bit more urgent. We've also assumed that humans and nature cannot coexist. Now, we talked about that, but if we confine our conservation efforts just to the places where there's not a lot of humans, we're going to fail, because those places are too small, too few, and too isolated. David Quammen has a great analogy between a Persian rug and an ecosystem. That is a functional Persian rug. That is not 71 Persian rugs. That's 71 rug fragments, none of which are acting like a Persian rug, and that's what we've done to our ecosystems. The UN designates biosphere reserves as places of ecological significance, and I don't like that language because it suggests there's places on planet Earth with no ecological significance. Not so. Every square inch of the planet has ecological significance, including our yards, including our corporate landscapes, including our roadsides, including our campuses, even including much of agriculture. So we need to glue our rug back together again, folks. We've got to put the plants back, not just to make biological corridors that allow plants and animals to move back and forth between viable habitats, but to recreate viable habitats in all those places where we've destroyed them. The good news is this is starting to happen. I am seeing this happen. And when it does, it'll be the first time in modern history that we humans actually have coexisted with the natural world. Our third misstep was to leave Earth stewardship to a few specialists. Few conservation biologists, few ecologists. For some reason, we didn't see it as an inherent responsibility of everybody on the planet. But I don't know why, since every single person on the planet depends entirely on the quality of local ecosystems. So why wouldn't everybody bear the responsibility of taking care of those ecosystems? Stan Rushworth, a Cherokee elder, once said, the Western settler mindset was, I have rights. The mindset of indigenous people is, I have obligations. You are not born with those mindsets, you're taught them. We're very good at teaching this. We've been terrible at teaching our kids and our peers that we all have obligations to good earth stewardship. That does not mean you have to save biodiversity for a living, but you can save it where you live, and if you do, it empowers you. More and more people are upset. They hear the news about what's happening on planet Earth, but they all feel powerless. What can one person do? Well, one person can shrink the lawn, one person can modify the lights, one person can get rid of their invasive plants, one person can fire a mosquito joe, one person can put in a pollinator garden, one person can totally revitalize the ecosystem on their property and then enhance their greater local ecosystem instead of continuing to degrade it. And it shrinks the problem down to something that's manageable for everybody. Don't think about the entire planet's problems. You get depressed. Just worry about the piece of the earth that you can influence. If you own property, it's obvious. That's where you start. If you don't own property, help somebody who does. Help a land conservancy. Help a park or preserve. They're all underfunded. They're all understaffed. They will love you as a volunteer. So as a property owner or a volunteer, each one of us has the power, and we certainly have the responsibility to fix dead landscapes like this. Whether or not we decide to do so is going to determine nature's fate and then ultimately our own. So I think I've convinced my grandchildren that you are nature's best hope. I hope I've convinced you as well. And I'm going to leave you with the Homegrown National Park Challenge. I want each one of you to plant one keystone plant this year. It'll take you 5 minutes. And you're thinking, well, that's not going to help much. Well, I want 400,000 of you to do it. So thanks very much.